The topic of this video is solving nonlinear systems of equations by substitution or elimination. Let's look at a problem. Solve the system using substitution or elimination. Your choice, choose wisely. Okay, so we have an important decision to make, substitution or elimination. The way we make that decision is we look at both of our equations and we see if we can find an x or a y with a coefficient of 1 or a negative 1. And as a reminder, when we say x or y, we mean x or y, not x squared, not y cubed, x to the first power, y to the first power. Okay, well, in this problem, we don't have any of those. This x is being squared, this y is being squared, this x is being squared, this y is being squared. That leads me to the conclusion that I should use elimination to solve this problem. The goal of the elimination method is to make term opposites. So I need signs to be different. I notice that in this problem, my y's in the top equation are positive and my y's in the bottom of the equation are negative. Therefore, y makes a good candidate for elimination. The trouble is, the top y has a coefficient of 4 and the bottom y has a coefficient of 5. We need to make them match. So, we use the 5 on the bottom as the number to multiply both sides of the top equation by, and we use the 4 as the top as the number to multiply the bottom equation on both sides. Here's what it looks like. 3x squared plus 4y squared equals 48. This is our first equation, which I'll label with a 1 with a box around it. Okay, so equation 1 will be multiplied on both sides by the 5 from equation 2. As a result, we will get 15x squared plus 20y squared equals 5 times 48, which is 240. Okay, now our bottom equation also needs to be multiplied by a number on both sides. So let's write our bottom equation. And the number the bottom equation will be multiplied by is 4. So, times 4 times 4, and the new equation will be distributing 8x squared, distributing minus 20y squared equals 4 times negative 37, which is negative 148. Okay, we're going to take our two new equations and we're going to put them together to form a new system. All right, so our new system will be 15x squared plus 20y squared equals 240, and 8x squared minus 20y squared equals negative 148. Notice that we have achieved our goal, which was to create term opposites. Once you have term opposites, you can eliminate a variable by adding your two equations together. Let's go ahead and do this now. All right, so when we add our two equations together, 15x squared plus 8x squared makes 23x squared. Notice the variable part does not change, but the coefficients are added. 20y squared and negative 20y squared combine to make 0. And 240 minus 148 is 92. But we'll check it with a calculator just to be certain. 240 subtract 148 is 92. Okay, so we've made some progress in solving our equation. The next thing that we need to check is, how do we solve for x? Well, we notice that we've got 23x squared plus 0, and adding 0 doesn't change anything. So this brings us to 23x squared equals 92. Remember, the goal is to get x alone, which means everything around it needs to go away. Let's get rid of the 23 with division. So divide by 23 here and here. We get x squared equals 4. Now apply the square root property. We get x is equal to plus or minus the square root of 4. The principal square root of 4 is 2, so x is equal to plus or minus 2. we get x equals negative 2 or x equals 2. Okay, so now we have to find the y values that go with these x values. And to do that, we need to plug back into one of the equations from our system. It could be any equation from our system, as long as that equation still has x and y in it, which means there are 4 obvious choices: original equation 1, original equation 2, modified equation 1, and modified equation 2. The modified equations have larger numbers, which make them undesirable. Of the top original equations, the top one has no negatives, all positives, which makes it the most desirable choice. So we're going to plug each of these values of x into original equation 1 to find the corresponding values for y. Let's proceed. Okay, let's start with x equals negative 2. So, plugging x equals negative 2 into equation 1 gives the following statement. 3 times negative 2 in parentheses squared plus 4y squared equals 48. Order of operation says that exponents happen before multiplication. So negative 2 in parentheses squared would be a negative 2 times a negative 2, which is a positive 4. Then multiply by 3, and you get 12. 12 plus 4y squared equals 48. To get y alone, everything else around it needs to go away. So first let's get rid of this 12 with subtraction. Minus 12 minus 12, 4y squared equals 36. Now get rid of the 4 with division. Y squared equals 9. Apply the square root property. Y equals plus or minus the square root of 9. Y equals plus or minus 3. Notice that we got 2 values of y for this one value of x. In other words, when x equals negative 2, y equals negative 3 or positive 3. This gives us 2 ordered pairs. Okay, we now need to complete this process again using the other value of x, the positive one this time. We'll use the same method. We go back to equation 1, we replace all of the x's with positive 2. Notice that I'm just going to do a little bit of erasing right here, and the rest of our algebra is valid. Because whether you have a positive or negative, when you square it, you're going to get a positive result. So when x is 2, then we plug in, 2 squared is 4 times 3 is 12, and the rest of the algebra is identical. Which means, when x is positive 2, y is again negative 3 or positive 3. And we get the ordered pairs 2, negative 3, 2, 3. Okay, so we have our 4 potential solutions. The only thing that's left to do is to check each one at a time to make sure that it truly is a solution of our system, and we'll do that in our next video.